Hi everyone, and welcome to the third video of the series about MySQL clusters. And this one will be the MySQL cluster, called also NDB or CG, different names that we use for the same thing. I call it MySQL cluster or NDB cluster. And this cluster is completely different than the previous cluster I showed you, the NDB cluster in the previous videos. It's a completely different topology, completely different technology. And this cluster is always active, master, whatever you call it, with no conflicts. And one of the unique features is it is scaled for writes as well. So you add more data nodes and you'll have a high scale. In our case, we are building this cluster, unlike before when it was all on one machine. Currently it's still running on my laptop, but on 4 different virtual machines. So we have 10, 0, 10, 10, 11, 12, and 13. And those will be our servers, and they're going to run the different nodes or processes. So the first thing we need to do is we're going to use MCM. MCM is MySQL Cluster Manager, as you can see in here. And MySQL Cluster Manager is a daemon that runs on all those machines. It's already running on the other machines as well. We are running everything on 10, but the other machines will have a Cluster Manager on them. And it helps us to set up a cluster and manage it. It's kind of like outside around cluster. It's not part of cluster, but it really helps setting up everything instead of setting up by hand, which takes a long time. So it really saves a lot of time. So the first thing we're doing, we create a site. A site is just tying up those cluster managers together as one group, and we have the different IPs. So we have 10, we have 11, we have 12, and we have 13, and they're all going to be inside a site we call my site. Very simple. So we set this up, and we have the site created successfully. The next thing is to add a package. Now, a package is basically just an alias name, in this case 766, which is the version of cluster I'm using. And it just tells the cluster where, or the cluster manager, where the actual cluster binaries are. In my case, in OPT MCM cluster 766. So we add a package, and the package is added. Great. Now, this is the main command to create a cluster. This is where we assign the different machines and their processes or nodes. So cluster has 3 types of nodes, 6 nodes running in a 4 machines setup. So 4 machines is the minimum. And we have 3 different processes that creates 6 nodes. So the first process called NDB MGMD. This is cluster management. Different than cluster manager. Cluster management is part of cluster. It's part of the 3 processes of cluster, 3 nodes of cluster. And management is what goes or walks around it and allows us to set up the cluster and manage it. So management, we have 2 of those. One will run on 10 and the other one will run on 11. And then we have NDB MTD. This is the data node, so NDB multi-threaded data node. We're going to have 2 of those. This is where the data is actually sits. Those are probably the most important nodes of your cluster, and they're going to sit on 12 and 13. Okay, 2 of those. Everything comes in 2s for redundancy. And then we have the MySQL D. This is the interface. So the way you interact, or your application interact with cluster, is not accessing straight into the data on data nodes, or it is by accessing the MySQL nodes that knows how to access those data nodes. So we have 2 of those as well, and they sit on 10 and 11. So as you can see, 10 and 11 are acting as management and MySQL, which is fine. So it's 2 nodes or 2 processes in the same machine, same node. And that's because MySQL management, cluster management is a very small, lightweight process, so it can run with the MySQL D. Never ever run this with a data node. Never. There is a reason, and if you want to ask me why, contact me and I'll explain why. Currently, just we don't have enough time. And then the last process that is basically wrapped here is NDB API. This is a C++ API that a cluster has. You have to have at least one of those because the restore program uses this API. You might need more if you have connectors that need the API, like cluster J or similar connectors. So if you need more, you'll just have to have comma and more and more and more. And the fact that we are doing asterisk means it's unmanaged. It's not on a specific IP. It will move to where it needs to be when we need it. It's like a socket. And then the name of the cluster, CL, again, me being lazy, I'm choosing short names, so I don't need to type long commands. And we create the cluster, and as soon as we create a cluster, you can see in here, this is a monitor of our cluster. We can see that we have nodes, so we have overall 6 nodes, but it's 4 machines. With 10 runs the management and 11 runs the management, data nodes here, and again the MySQL nodes, and the API with no IP. But they're not started, they're just added. Now, the one thing I'm going to run basically a set configuration commands just to run things smoothly. And now we can start the cluster. So we start the cluster. The way the cluster starts up is first the management coming up. We need management for the other nodes to know what the configuration is. And then the data node will start up. They will do initial start, which means that they're bootstrapping all the file system, since they haven't started before ever. And then the last one will be the MySQL nodes. The API is not starting, it's a socket, so it doesn't start. So let's start the cluster and see how it goes. So we have the management running. Now the data nodes are running and initial themselves. And when they're done, the next one will be the MySQL interfaces. The MySQL D interfaces now starting up, and we're done. So the cluster started, it took us about 18 seconds on my laptop, which I think is quite nice. Okay, now next. Now I'm going to do, I'll just clear the, this looks a bit nicer. Now, what I'm doing now is called consolidate user privileges. And the idea is that the MySQL data nodes, MySQL interfaces are basically regular MySQL servers. And so they manage the privilege or user privileges inside themselves. But when you have a cluster, you don't want to go to each of the nodes and change each of the users and create users and change passwords. Cluster allows you to push down the privileges down into the cluster, so it will propagate across them all. And this is exactly what we do. So we are inputting a set of SQL commands, we're running store procedures, and then we just restart all our MySQL interfaces, and then it's done. And now I can create a user, which is exactly what I'm doing now. I'm doing it on my node, but it will propagate across to the other node as well. Next thing we need to do is to set up the router. So I'm setting the router with, this time again, just one routing rule, 6446 for read and write. This is a multi-master and no limitation. There is no mode of single primary in this cluster. It's just multi-master, but it takes care of everything. And we have 2 destinations. One is 10 and 11 on port 3306 and 3307. I change this, the second MySQL into 3307, and that's because later I'm adding another one and I'm going to show you, and it's going to have 3306 as a default. So I'm just changing it. Great, so we created the configuration file and we are starting the router. Great. Now before we can start the application, we actually need to go here to the configuration file of the demo and change the IPs of our MySQL interfaces. This is for the router, right? For the router and for the demo to show you read and writes. So the 2 servers are 10 and 11, and the router is going to be in the ports going to be 3306, 3307. The router write is 6446, and the read is 6446. because it's multi-master. And again, this is the extended demo. So when we're extending, we have another, we're going to have another MySQL interface, and it's going to sit on 11 on a different port. So now you can see why I changed this to 3307. Right, now we can start the demo. Okay, so we're starting the demo and we choose the NDB cluster, and it starts up, and we have the two servers up and running, and we can start the actual transaction. And immediately you can see that we have a split of read and writes between those two machines, which is exactly what we wanted. That's cool. Now for the next part of the demo. So the next part will be to have a disaster. Now our kind of disaster going to be, I'm actually going to shut down one of the data nodes, completely shut it down, and then restart it. Now when we do this, you will see that there is a hold. So let's do it. Let's just shut down this machine. So I'm completely shutting it down, and you see that as soon as it shut down, the application stops, and it will stop for about 3 to 5 seconds, depends on my laptop and how busy it is, and it's quite busy right now. You can see it's now saying it failed, and the cluster now gives this machine that was gone away, gives it a 3 heartbeats to make sure that it's actually gone and not just have a network issue, or maybe the network is flaky, or the CPU is busy, or all sorts of weird stuff that can happen. Just ignore the fact that the graph looks weird. That's just information that comes to the graph while everything is in hold. It will be fixed in a second. But so we give the machine some time to recover itself and maybe come back. But if it's not coming back, then the cluster goes back into operation. So there was a stop, and then you can set how aggressive this stop is. I'll just start the machine in the meantime so I can show you what's next. So you can set how aggressive this stop is. In my case, my laptop is very busy, so it takes a bit of time. You can make it very aggressive, but if your network is flaky, that means that machines will be evicted from the cluster all the time, and will need to restart. And it's not a pretty sight. So I won't do it on a normal operation. Hopefully this machine comes up, and what we need to do now, it won't join back to the cluster because there is no auto start for those processes. We actually need to run the cluster manager. We could do auto start for the cluster manager. I didn't for this demo to actually show you what I'm doing, but I will try to SSH to this machine, and yes, it's up and running. So we are now logged into 13, which is the failed machine. And all we need to do now is just start the cluster manager. As soon as we start the cluster manager, you will see that soon enough, cluster manager starts the data node. The data node recognizes that it's part of the cluster. It recovers, get all the changes that happened while it was down, and it will join the cluster. Now, unlike the previous cluster, the NDB, if the cluster was running for 2 years and you had a disaster and you have a brand new machine comes from the box, you still don't need to do any initial load. All you have to do is exactly what I did now. Put the binaries in the same place, start the machine, start cluster manager, and cluster takes care of everything, including the complete initial start of all the data that is in that was in this cluster to start with. And then we fully recovered. So that's it. The cluster is up and ready. The next thing we're going to do is extending the cluster. Okay, so to extend the cluster, first let's change our demo into the extended demo. So again, we have the same demo. We'll start it. We have the two machines up and running and accepting all those transactions. That's cool. And the third machine is still doesn't exist even. So it's not there. So let's edit. Now the way we're going to do it is again using the MCM, and we're adding processes. Now in my demo, I'm adding I'm adding the data nodes and the MySQL. So 2 data nodes and a MySQL node. So my cluster is going to be much bigger. I'm extending or scaling this cluster quite big, but I'm running it on the same machines that I already have on 12 and in 13 as a second data node on the same IP. and a second MySQL on 11. In real life, you will have a couple of more commands to actually add the hosts with the new IPs. Given that we had it, all we have to do is just add those nodes. And this process is going to take a bit of time. You can see that now in our monitoring, we have those processes up and running. And now the cluster doing something very interesting. We call it rolling restart. Rolling restart means that all the processes will now restart themselves, but the application won't stop. And that's why we have the application running over there. That's just to show you that even if the cluster goes into a complete restart, the application or the database doesn't go down. It's always up, which is what's so unique, one of the things that are unique about MySQL Cluster. It actually allows you to do software upgrades, so upgrading MySQL Cluster, or operating system upgrade, or even refresh your hardware. You can actually change your hardware while you keep the database up and running. If you do it correctly, this database is not supposed to go down ever. It is classified as 5 nines, and as far as I know, we are going to classify it as 6 nines. So it's a very high available system. Now, one interesting thing, you can see that now the data nodes goes down, and the application is not stopping. And that's because when a data node goes down gracefully and not just disappear, it will actually announce it's going down, and there will be no hold for the application. So if you do need to restart your cluster doing a rolling restart, you don't have to wait. You don't have to be worried about, it will be, the application will stop for this, 5 seconds, and I can allow myself to have it. It's not a problem when if it's not a disaster, there is no stop. You can see that the data node stopping now, application is keep on running. So not a problem whatsoever. The reason why we're doing running restart is because all the processes needs to be announced with the new hosts that are currently running. So they need to reread the configuration from the cluster. And that's why the processes are doing restart. So we let this finish. We are waiting for this data node to finish starting up. And then the MySQL will go down, and you'll see, here you go, we just lost one of the MySQL nodes, but the application is not stopping because we have the other one that is taking care of all the load for it. And then when it starts up, the other one goes down, and this one takes care. So you can see the application is not stopping at all. It's all just keep on going. And we're done. It took us about almost 3 minutes, and we're up and running. Great. Next, we have to start those processes. You can see they are added but not started. So we're now starting them. You'll see that first the 2 data nodes will start up, initialize themselves, and receive a new node group. So each 2 data nodes creates a node group, and that's how they split the data between them. So those are now starting up, initialize themselves. And lastly, we will see the MySQL interface coming up. Now, when the MySQL interface comes up, if you look at the application, and I'll make it a bit close up, you'll see that as soon as the node comes up, immediately it is synchronized with the rest of the nodes. And that's because the MySQL interfaces are not holding any data. They just look. So have a look. It just came up, and immediately the number of transactions is the same as the other one. And that's because they are not holding any data. They just access data that is in data nodes. So there's no recovery for the MySQL interfaces themselves. However, the application is not accessing this node because the router knows nothing about this node. Now, the next thing I'm going to do before I'm changing the router is I'm going to reshard tables. Reshard basically means we recut the tables between those different nodes. So now we have a new node group. We can cut those tables into half between those 2 node groups, and this is why MySQL Cluster can scale writes as well. And you can see that this operation is online as well. We are cutting, resharding online. We're organizing the tables. We are moving actual rows. I'm moving now from the old servers, the previous data nodes into the new data nodes. And that's it. It was all done, and it was all online. And now we can update the router. So updating the configuration for the router and restarting the router. Now, router is supposed to be redundant as well. So when you stop and start them, you should do it making sure that you're doing it one by one and making sure that everything is good. Now, the dips you see in the graphs are just because my laptop is just too busy running all this and recording the video. So this is the dip. It's not because we had any issue with the cluster. And now we can see that the new node is playing around with his friends, and everything now is split between all those nodes. And that's it for MySQL Cluster. If you have any question about MySQL Cluster or any of the clusters or any other question, please feel free to reach out to me. I won't leave my email, otherwise it'll get spams all across, but it's really easy to find me just with my name. I'm Ronen Baram. Thank you very much for watching, and have a good day. Bye-bye.